Hi. Well, today we're going to talk about certain kinds of um, word problems, kind of special word problems that we're going to be dealing with. And this is in 5.6. It's on page 333. And these are sort of specialized, special algebra problems. We're calling. And the first type is what we call a work problem. They, they usually have kind of a not exactly a formula, but they have a certain strategy that we use on all these problems. So work problems have a certain strategy. And what we do is we try to put working together, the time it takes to work together over working alone by themselves. A worker might be working with somebody else, and he could be working by himself. So we put the amount of time it takes working together over the time it takes working alone. And then we're going to create some fractions here, and we're going to set it equal to one job. One job. So let's look at this first problem. It says filling sandbags. The Sandbag Corporation sells machines that fill sandbags at a job site. The sandbagger, a special kind of machine, can fill an order of 8,000 sandbags in 5 hours. The multi-bagger can fill the same order in 8 hours. If all machines are working together, how long would it take them to fill an order of 8,000 bags? So I ran through this kind of fast, but most people might think, okay, I just add the 5 and the 8, that's 13 divided by 2, get 6.5 hours. But that's not exactly the solution. The other thing they throw in is sometimes they throw in extra wordage or things you don't need. Like we don't need to know how many bags they're filling. We don't need the 8,000 bags. Okay, interesting, but that's not what we need. So let's go through this and read it. If you have your book, you can kind of see it in detail. So it says the one machine, the sandbagger, which is called sand. It says it can fill an order in 5 hours. That's by itself. Working by itself, it can do it in 5 hours. But working together, we don't know how fast that's going to be. So we're going to call that X. Plus, the other machine, these are going to work together. The multi-bagger, we just put multi. It can do the same job, but it's a little slower. So it takes 8 hours. Okay, so they have a demand for this sand. The river is rising. It's going to be flooding. They need to get this together. They said, let's run both machines at the same time, and see how much we can get done. So they're going to run both machines. This would also by itself be X. We don't know. But it's going to equal not 8,000 bags, but just one job. It's going to equal the number 1. So, and to do this, remember from last lesson, we're going to use our magic number. And our magic number is going to be 5 times 8, 40. 40, 40, and 40. Let's put this 1 over 1. 5 times 8 times 1, 40. So 5, we're going to get rid of these denominators just like we did before. 5 into 40 is 8. That'll give me 8x. 8 into 40 is 5. 5 times x, 5x. 40 times 1, 40. So we've reduced this problem so we don't have these fractions. We multiplied everything by 40. 5 into 40 goes 8. 8 times x, 8x. 8 into 40, 5. 5 times x, 5x. 1 into 40, 40. Let's cancel off that 1. 40 times 1, 40. Now let's add them together. 13x equals 40. And we're going to divide. We can use our calculator or whatever. 13 into 40 should go 3 times. X is 3. That's 39. From 40 is 1. 3 and 1, 13. So just a little bit over 3 hours working together, they would figure it. If we did it by the other method, we figured it would take 6.5 hours. But it's going to take closer to 3 hours, maybe just slightly over 3 hours. 3 hours and 5 minutes or something like that. If we did them independently, so working together, both these answers are the same. 3 hours and 13 minutes, or 3 hours and about 3 hours, 3 hours. Okay, working alone, 5 hours, 8 hours. If we put them together, this one's going to slow down this machine a little bit, but together they're still going to be a lot faster. So it's kind of a specialized kind of problem. Okay, let's try another one of these. Okay, so here's a problem that's interesting to read. Take my little paper here. A convention planner is organized in a big business luncheon for 2,300 guests. Okay, first of all, we don't need to know how many guests. Okay, probably not. The chosen menu will include tacos and tamales. Even though that sounds good, we don't need that information. Useless. To complete the order, 2 food caterers are needed. Okay, that's important. Reading that Grace's Kitchen won the 2013 Twisted Taco Throw Down. The owner wants to hire Gracie. We don't need all that information. All we need is Gracie. Gracie is here. And what about Gracie? Suppose Gracie and a second caterer. So they're going to have a second person, unknown person. Okay. The organizer wants to hire Gracie and as one of the caterers and a partner. And they can complete the job together. Let's see, and a second can complete the order in 12 hours. So working together, we'll put WT, working together, it's going to take them 12 hours. If the second caterer would take 10 hours longer than Gracie, 10 more hours by themselves, longer than Gracie to complete the order alone, how long would it take each working together? So they threw out a lot of useless information. Tacos, 2,300, the twisted taco truck throw out. We don't need all that. So the problem is basically this, working together. We'll abbreviate. This is problem number 2. Working alone. Okay. We have Gracie. We have an unknown person. And what are they going to do? They're going to do one job. Okay. Now, what did they tell us? Working together, they figured out that these guys have done these jobs before. It takes them about 12 hours. So the numerator, the numerator on both these problems is 12. It's the same for both of them. Now, this person takes 10 more hours than Gracie. So Gracie would be X hours, and this person's a little slower. So if they were working by themselves, it would take X plus 10. So this is our equation. 12 over X plus 12 over X plus 10 equals one job. So you have to kind of go through it, and you might have to read it over several times to try to figure out. What does X stand for? X equals the time working alone. That's what X stands for. So we want to put that down. Okay, the time working alone. So how do I get rid of X and X plus 10? A lot of times we think, oh, we'll just put an X plus 10. Remember, we have to multiply these together. We have to multiply X times X plus 10 times 1. So this is X times X plus 10, X plus 10. We don't need to write down to 1. X plus 10. So here the X's cancel out. and we get 12 times x plus 10. Here the x plus 10s cancel out, and we get the 12 times x. And here the 1's cancel out, so we get x times x plus 10. So now we're going to multiply all this out and see what we have. We've got rid of the denominators, but we've got kind of a mess. So we get 12x plus 120 plus 12x equals x squared plus 10x. So this is what we ended up with. Pretty long equation. And let's see if that's pretty close to something they had. Well, they used h's, and it gets a little confusing. So what we're going to do is we're going to set this equal to 0. So let's take this, let's move everything to this side. Okay, to set it equal to 0. We got x squared plus 10x, and here's 12x and 12x. So I move it to the other side, that's 24x. But it was plus 24, now it's going to become minus 24. We want to make sure, cross the line, change the sign. And then we're going to bring the 120 over, but we're going to make it minus 120. So what we have is we have 0 equals x squared minus 14x minus 120. So now I have to factor this down. Well, I know that these two numbers, the difference between these two numbers has to be 14. So if I took, because I have to subtract them, this is saying subtract the two numbers. So I'm going to put my calculator here. Let's take 120, turn it on, clear it out, 120 and divide it by 2. Okay, 60 minus 2 is not going to give me 14. I need to come up with 14. I'm subtracting these two. Let's divide it by 120 divided by 4. 30. 30 take away 4 is 26 now. Let's take the 120 and divide it by 6, because that should go in evenly. Good. 20 take away 6 is 14. So this must be x and x, 6 and 14, 6 and 20, excuse me. Now I want it to be a negative 14, so this would probably be negative 20 and a positive 6, huh? Would that add up to negative 14? Yes. Will it multiply to give me negative 20? Yes. So let's see our answers. X plus 6 equals 0. Solve it. X is negative 6. Now, we can't have a negative answer. So, I mean, it wouldn't make any sense. X minus 20 equals 0. Bring over the 20. X is 20. That makes sense. So let's put this back into the problem. Working alone, so Gracie was X, and working alone, she would be 20. It would take her 20 hours by herself. Now, other person is X plus 10. So working by themselves, 20 plus 10, that would be 30 hours. So by herself, she could do it in 20. This person would take 30, but together, it takes them only 12 hours to do this job. So this is actually the answer to the question. The question was, let's go back and try to find the question. It says, how long would it take each working alone? Each person working alone. So we have to write them separately. X for 20 and other person 30. Okay. So that's one type of problem. That's called a work problem. Another type of problem we can use is what we call proportion. Proportion is probably the easiest way to solve problems. Majority of problems are actually solved by proportion. So let's try one here and see if we can find it. And we kind of set it up. So let's see if we can solve this problem. It says, suppose it takes 8 gallons to drive for 120 miles. And we want to determine how much gas it would take to drive 550 miles. So that's the problem. It takes 8 gallons for 120. How many gallons for 550? So the way we set up a proportion is we set up the two things we're trying to find: gallons, that we know, gallons and miles. So on the first one, it was pretty easy. It says 8 gallons of gas to go. We're going to make this a fraction, to go how far? 120 miles. So we set up as a kind of a ratio, 8 gallons to 120 miles. Now, what is our final outcome supposed to be? We're going to try to figure out how many gallons, X gallons, we don't know, to go 550 miles. See, so I'm putting the gallons on the top and the miles on the bottom. Well, how are we going to solve a proportion? Remember, we can crisscross these. 120x equals 8 times 550. So I'm going to multiply 120 times x and x times 550. 8 times 550. And that's 4,400. Now, how would you solve this? Well, yeah, you would divide by 120. So I've got my 4,400 already. Divide by 120. It's going to take about 36.7 gallons. Roughly. I rounded it to 1 decimal place. So proportion is an easy way to solve problems. We compare something to something. In this case, 8 gallons to 120, x gallons to 550. Gallons on the top, miles on the bottom. And that way we can combine them. Okay, let's try another one. I'm moving right along here. Example 3. Jaden, who weighs 170 pounds, will burn 345 calories in 45 minutes while hiking. How many calories will he burn if he hikes for 2 hours? Again, we don't care how much he weighs, okay? We're talking about calories and minutes, or calories and hours. Okay, so we have to kind of, that's what we're working on. That's what the final question is: how many calories? So calories, and I'm going to put minutes on the bottom. Minutes. So when he's hiking, he burns 345 calories in 45 minutes. So we can set up like that. Okay, now he says, how many calories, X, will he burn when he bikes? He's riding a bike. Oh, if he hikes further, okay, he's still hiking. Okay, how many calories is he going to burn if he goes longer, 2 hours? Well, think about 2 hours. How many minutes are there in 2 hours? There's 60 minutes in each hour, so 60 times 2 is 120 minutes. Okay, so that way, it'll be a lot easier than trying to convert minutes to hours. Convert to the small thing. 45 minutes, 120 minutes. So to solve this problem, 45x equals 120 times 345. Multiply it diagonally. So 120 times 345. 45x equals 41,400 divided by 45. X is, bing bada bang, 920 calories. We want to label these that he burned. Okay, pretty easy. This one's an interesting one. Here's another proportion one. Wild horses still exist, at least in 5 states. To estimate the number in Arizona, in fact, we see this on the news every so often, a ranger catches 383 wild burros. I thought they talked about, wild burros. I thought they were talking about horses. 383 wild burros and tags them. Then he releases them. Later, 103 burros are caught, and it's found that 11 are tagged. Estimate how many wild burros there are in Arizona. Sounds like a pretty difficult problem, huh? So let's see what he did. He caught 383 burros, rounded them up, and then he tagged them. Okay, so what we're going to do is we're going to compare. And what are we trying to find? Trying to find how many there are. What's the total number? So we're going to put tagged over total. Now, when he caught his burros, we might think that that's the total, 383 burros. That was the total he caught. But what did he do to them? He tagged them. So these became tagged burros. We don't know how many are out there. He just found 383. There might be 384 out there. We don't know. There's more. So the next time he gathers them up, he finds that he gets 103 and 11 are tagged. 11 are tagged out of 103. So it's kind of a neat problem. 383 originally tagged out of, we don't know how many. Next time he catches them, 11 tagged out of 103. One nice thing about solving these, it's pretty easy. 11x equals 103 times 383. 11x equals what? 103 times 383. Somewhere here. 39,449. Then we're going to divide that by what? 11. And this will give me x. Okay, there was 358, 3586.27, but we're going to round it off to just 3,586. They came up with 3,009. They came up with a slightly different answer. Did I write down the wrong numbers? Maybe I multiplied it wrong. Let's go back up here and see. 103 times 383 divided by 11. Okay, yeah, no, this is correct. 3,586. We can't have a part of a burrow. I mean, it's like you either got a whole burrow or you don't have a burrow, So roughly 3,586 burrows out there. Okay, pretty cool little problem, huh? So, okay, the last type of problem is what we call distance, rate, time. Rate times time equals distance. Rate times time equals distance. But sometimes we have the distance, we want to find the time or the rate. So rate equals, all we got to do to solve this is divide both sides by t. Rate equals distance divided by time. Or time equals distance divided by rate. Okay? In other words, if we want to solve for r, or we want to solve for t, we're going to divide both sides by r. These are going to cancel. So time equals distance over rate. And we're going to kind of use these to help us solve some problems. All right. So it says a racer bicycling is bicycling 50 kilometers per hour. Faster than a person on a mountain bike. This is a racer. If the time it takes to get the racer to travel 80 miles, the racer travels 80 miles, This guy on the mountain bike only goes 40 miles. So we want to figure out the speed of each bicyclist. So this guy's going 15 kilometers per hour. That sounds like it would be a rate, but I'm not sure. So let's see if we can kind of set this up into a little problem. Sounds a little confusing, huh? So we know that rate times time equals distance, right? And we know that this racer, let's put the racer here and the mountain bike here. Okay, and I usually abbreviate. Okay, so this is the distance they're going to go, 80 and 40. Okay. So what is the question? It says find the speed of each bike. This actually is the speed of the racer bike. It's faster than this one. So if he's going 50 kilometers per hour, faster than this one, he's going, this would be, mountain bike would be X, and he's going 15 faster than that. He's going 15 plus the X. But the time we don't know, so the time we're going to will be constant. But what does time equal? Time equals distance over rate. And the time is the same for both of these guys. It's an equal amount of time. It says, let's see, if the racer takes it, the person has gone, find the speed of each bicyclist. So the time is going to be constant. So we're going to have 80 over 15 plus X over the rate is equal to 40 over his rate, X. So distance over rate equals distance over rate. It's a proportion. We're going to cross multiply 80x, but here we're going to multiply 40 times 15 plus x. So this is 80x. This is 40 times 15. Let's move this up a little bit. 40 times 15 is, not going to get it that way. Got to have the calculator on. 600 plus 40x. How could I solve that equation? Bring the 40 over. So 40x equals 600. So x is 600 divided by 40, 15. Now, does that answer the question? No. The question is find the speed of each bicyclist. So the rate is R. The mountain guy, the guy on a mountain bike is going X miles, so he's going 15 kilometers per hour. But the speeder, the racer, is 15 plus X, so that's 15 plus 15. He's going 30 kilometers per hour. Whoops here. So we want to make sure that when we answer the question, we're actually answering the question. 15 gets us to the answer, but the actual answer is how fast are they going? This guy was going 15. This guy was going 30. He's going twice as much. And it makes sense because he covered twice the distance, 80 and 50, 80 and 40. So that's how I would set that one up. Okay. Now let's see if we got one more here. The river barge travels 98 miles downstream in the same time it takes to travel 52 miles upstream. The speed of the current is 2.3. Find the speed of the barge in still water. Okay, this is kind of a classic problem. Okay, so And again, maybe using a table here wouldn't be such a bad idea. Rate times time equals distance. We have a barge that's going downstream and then it goes upstream. So it tells us something about the distances. Going downstream, it can travel 881 in the same amount of time it travels upstream, 52. And it wants to know what's the speed, the rate. Okay, now the times are held equal. So let's just say equal. So what we're concerned with now is trying to figure out this rate. And it says the speed of the current is 2.3. So the rate going downstream is x plus the speed of the current. It's actually pushing the boat, making it go faster. That's why it can cover more area. When it's going upstream, it's fighting the current. So it's x minus 2.3. So what is time? If we know time, time equals distance over rate. So if we take the distance, 98 over the rate, x plus 3, and this is equal to the same amount of time, 52, but x, this is 2.3. X minus 2.3, we should be able to figure this problem out. So cross multiply 98 x minus 2.3 equals 52 x plus 2.3. Let's multiply that out and see what we get. 98x minus 2.3 times 98 225.4 equals 52x plus 2.3 times 52. Let's see if I got it right. 119.6. Okay, let's bring the 52 over here, minus 52x. Let's bring the 220, this was minus, let's make it plus 225.4. So let's calculate here. 8 take away 2 is 6, and of course you could just on your calculator. 46x equals 10, carry the 1, 15, carry the 1, 4, don't carry anything, 3. 345. So it's going to be 46 into 345. 345 divided by 46, 7.5. So this is the speed of the boat in still water, because both of these were the same, x's and x's. Speed of boat, or barge in this case. The speed of the barge is 7.5. And that's what we had to figure out. What was the speed of the barge? And the barge is traveling at 7.5. And that's what they came up with. So in this case, X was the answer. 7.5 miles. Is it miles or? Yeah, miles per hour. Okay, so you might have some questions on these. You might want to ask some questions, but you want to give it a shot and see what you can do. So some of these are pretty hard, some not so hard. See what you can do. And if you get real stuck, then see if we can get you out of that mess.